All right, well, welcome everybody to session two. Thank you for joining us again. And welcome if you didn't make it in last week, but you've joined us today. It's great to see you all. I think I'll just pass directly over to Nick and we'll get cracking. The same as last week, if you have any questions, you can post them in the chat, post them on the Discord, and I'll try to make sure they get through to Nick somehow eventually. And we'll also be available for questions between sessions if anything comes up. But otherwise, I hope that you enjoy the session today and that nobody's computer just completely overheats from running Zoom and GIS at the same time. So Nick, I'll hand it over to you.
All right. Thank you, Claire. And good morning, afternoon, evening, wherever you are. This is going to be, our second session of QGIS, GIS for Geoscientists. And I want to start today with just some housekeeping bits and also sharing some sort of interesting resources that might help you in your further QGIS learning. And I want to thank you all for being here, if I haven't already said that. The first thing, please fill out the feedback form I sent around last week. It was kind of a last minute thing that I put together, but I'd really like to know, where everyone's from, mainly just for my own curiosity, and I'd love to improve my teaching delivery. So we have a few responses, and I've enjoyed the responses that I've read so far. But it'd be great to get some more data on this. Also, if I know where you all are from, I can show you some really cool maps. So maybe some different map techniques on how to interpret that kind of data. So this would benefit you if you do fill it out. We can find a way to make it engaging. And Claire's posted that in the chat if you don't have that link open anymore. All right, and this is a question that I got last week, and I promised that it would be talked about this week. So this is resources for further learning. There is now a tab, or there was a tab, but now it's been reorganized on the GitHub that has a range of different textbooks as well as some publications that just sort of point you in the right direction with learning more about QGIS and GIS more generally. I'm going to highlight a few of those here. So there are two textbooks that are really easy to access, really kind of good for introductory learning. I've highlighted them here. I believe the Huysman and Dubai textbook, this is actually the textbook I've used to, as kind of a baseline to help design a lot of this course, especially with regards to some of the material last week, the sort of fundamentals. It's a really accessible book. It goes into a great bit of detail on some more advanced topics. So if you want to learn more, it's there. And the really nice thing about it is it's distributed under an open software license. So, free for any of you to use. So I definitely encourage you to look up that. Geospatial Analysis by DeSmith is another good one that I've used before in my teaching. And then I have some screen grabs here, some different books that will be helpful for you. So I talked about How to Lie with Maps last week. That's one of my favorite sort of general science books about cartography and great for thinking about map design. This handbook here, if you yourself are an instructor, this could be a very useful laboratory manual. It comes with some test data sets. It might be a bit out of date at this stage. Maybe they'll do another re-release of it, but it's relatively affordable and has a lot of rich detail on how to achieve certain tasks. Learn QGIS, distributed through PACT, is another great one. Anita Grasser, who's the author on this book, she is a great resource for learning how to actually use GIS. Her website, her Twitter, and her various textbooks. So I would definitely encourage you to pick this up. It's usually available on sale for pretty cheap. And Anita is very active on Twitter, so you can follow along and see some of the stuff that she does. I should also note that with all of this, I don't benefit from recommending any of these things to you. I just know these are resources I've used and that I just want to make sure you have. And then finally, Bolstad is one of the classic textbooks, bit expensive, but really high quality textbook on GIS. And this is something I got recently, again, Anita Grasser. This is something I got for Christmas last year. So this is a very recent addition to my library, but it's a map design book. It shows you step-by-step how to do some of the more advanced kind of design elements of QGIS. And it gives some great inspiration on how to make really beautiful maps. So all told, a lot of resources here you can work with. This is only scratching the surface. There's a ton of resources on the internet on how to learn GIS. I'm just one of many people who knows how to use it and talks about using it. So definitely give these a look if you're interested in that kind of thing. All right, sorry, just checking the chat, making sure everything's good. The other thing, if any of you are on Twitter, I would encourage you to check out the hashtag 30-day map challenge. This month, every November, every year, a group of geospatial scientists, they organize this month-long challenge to kind of showcase your skills in map making. And I've pulled just a few of the really pretty examples I saw, in the last 2-3 days off of Twitter. These are just some random accounts I saw. It's really neat posts. So I would encourage you to check this out for inspiration and to kind of get an idea of what you can actually do with GIS. And finally, a bit of a plug here. I sort of made my way into GIS through research I did on the Deccan Traps with a range of people at UC Berkeley, Drexel University, and the Open University. And just so happens my colleague at the Open University, Ann Jay, is advertising a PhD project that involves a lot of GIS. So I thought I would just do a shout out here for any masters or undergrad students who are looking for a PhD next year. There's this really neat project on the Deccan Traps. So very volcano-y and also has a strong element of GIS and photogrammetry. So if anything here is appealing to you and you're really interested in physical volcanology, I can attest to how great Anne is. And I encourage you to drop her an email and ask more about this project. I wish I could be more involved with this project because it's really neat. All right, that's all kind of the beginning bit out of the way. Now, what are we actually going to get to today? Today is going to be your crash course introduction to the actual application of GIS. Last week, we went through why we might use it, sort of the principles of using GIS, and I gave you kind of an overview of how the software looks and where the buttons are. This week, we're actually going to start importing data, manipulating that data, and trying to make a map. This exercise was designed to take a bit longer than the time we have today, so we may not get to every single bit of the session 2 guide. And if you've taken a look at that, you know it's quite extensive. I have not spared any expense with regards to detail. So you have plenty of material to work off of in your free time if you want to kind of do this exercise on your own. My goal today is to showcase the skills, talk you through why we're going to do these different tasks and how you do them correctly, with a goal of getting to this map designing step. And whatever we don't finish today, we'll try to pick up next week and in future weeks. So we have a lot to cover. So I'm going to try to move relatively quickly, but thankfully, since this is all recorded and will be shared with you, you can always listen back and try to catch up and watch some of the things I've done or refer to the PDF guide. So I hope you're as excited as I am. This is always the most fun day because it's a lot of experimentation, and for a lot of you, this will be your first time diving in. So let's just get right to it. So I say let's get right to it, and then I have to talk to you for a moment. Making a plan. This is the most important step. As with everything I've said last week, you have to do a lot of pre-planning before you actually dive into QGIS. Otherwise, you're potentially going to run into problems down the road if you haven't clearly defined what you're doing and why you're doing it. So so this is more of a general point, and this is something I also stressed last week. You need to critically think about where in my research or professional life workflow does GIS fit in? Is this something that I'm using to gather data that I'm then going to interpret in another software or another way down the road? Is GIS just my map making tool that I use to make figures just before I submit a publication? Or is GIS like an intermediary stage where I've gathered some data from the field, I run it through GIS, do some analyses, and then I take that data and interpret it further before getting to the final product? That question, the answer to that question, whether it's sort of an early, mid, or late sort of tool to use in your workflow, will shape how you approach structuring a GIS project. And I give an example here about planning stages. So, I hope some of these kind of ring some bells for you about ways that it could be useful. Before you go out and potentially do a field campaign, it's very useful to go through GIS, pull in some data sets, and try to plan perhaps prospective sites for outcrops or prospective, locations you're going to fly a drone to monitor a volcano. You can do a lot of that just off Google Earth and base maps, but doing it in GIS gives you that benefit of spatial accuracy and the ability to do some analysis alongside cartography and sort of just general map design. So it gives you the flexibility to do a lot to prepare for your field work. Later on in your project, GIS's value is going to come in and what sort of analytical, power it can give your model. So you want to take all these questions on board when you're addressing your own research. And the exercise I've designed for you, outlined in the session 2 guide, it attempts to answer these questions by setting up a very specific scenario. This is not necessarily, 100% a real world scenario. It's somewhat contrived, but the point being that it tries to hit on all these questions to give clear answers as to why we're using GIS in this circumstance. So take these on board, make sure you make a note of these, and keep these in mind anytime you're using GIS. So our scenario today, and really through the rest of this workshop series, is concerning a volcano called Pichincha in just northwest of Quito, Ecuador. This is a very active volcano. It's erupted several times in historic time, as well as in the modern day, in the past century. The question that we are going to aim to address in today's exercise specifically, and we'll build on in future exercises, are how many people are at risk of hazard exposure to the different eruptive products of Pichincha, just outside Quito. There should be a comma there. This is encompassing 2 main hazards we're going to concern ourselves with. And as any volcanologist here might be able to contribute, there are many other potential hazards at play and lots of other more detailed considerations. But I've tried to simplify this problem so that we can address it in GIS easily as beginners in this workshop session specifically. So we're primarily going to be concerned with lahars. The data we have, I believe, includes both primary and secondary lahars. And then we're also going to take into consideration ashfall, which obviously has a huge impact on the structural integrity of buildings, as well as the operation of aircraft engines. Any volcanologist here should hopefully be able to take that on board. The role that we're going to kind of fit in this sort of fictitious scenario where we're answering this question is we're a GIS scientist, either working for an Ecuadorian university or public institution of some kind, perhaps a government agency. And we're a GIS scientist who's been asked to answer this question by people who have to make decisions about this hazard and how they should respond to a potential eruption. So you can imagine in this hypothetical scenario, there's some signals that are potentially worrying coming out of Pichincha. Perhaps an eruption is forthcoming, and so us as a GIS scientist, our job is to basically provide our managers with a data set that allows them to make informed decisions about who needs to be evacuated from where and what the projected impact would be of a given eruption. And this analysis itself is also going to be quite simplified. There are lots of dimensions here that we could get into and analyze, and I hope in the Q&A some of you pull this out and think about what some of the broader implications are of this project and how we might potentially expand on the simple kind of the very narrow question that I've set up here. All right, so that is it for the intro. The final bit I just want to note, and this is something that I came across later on after I designed this exercise, was just we're going to be using data sets and thinking a lot about communities in and around Quito, Ecuador. And it was only after I designed this exercise I realized that the volcano itself is actually a really important part of Ecuadorian history. So just to make a sort of an aside note that this is another instance of volcanoes being really important for human history, and perhaps kind of connected to that, let's make sure we have a lot of respect for the data and sort of the question that we're asking here, because there are real people living on the slopes of this volcano, and this is a real active place. Even though this scenario in particular is contrived, this, overall the possibility of disruption happening is possible. So let's just make sure we're respectful. All right. So that's the setup. I'm feeling pretty good about the timing. So how this is going to work going forward for the rest of this session and for the next several workshop sessions is we are going to work through, I'm going to have slides where I'm going to showcase a particular tool or technique we're going to use. I'm going to close down the slides, and then I'm going to go into QGIS and I'm going to perform that task while giving some narration. This will get better as I go. It's obviously a bit of a strange transition given that I'm sharing one screen and looking at another. So you have to bear with me as I transition between the different mediums. But it should be a good way to keep this live and interactive. And as I said, we'll just go as far as we can with the lecture slides today. I'm hoping we can get to the end, but if you all have lots of questions at the break, and we'll probably take our break in about 35 minutes. If you have lots of questions at the break, then maybe we don't make it to the very end, but that's okay. Just want to make sure everything's looking good in the chat. Thanks for that, Claire. I just saw that message from Divya. Hope everything's good now. Okay, so our first task is importing data. Now, I did talk about this last week, but some of you may not have been able to attend last week. I heard there were some time zone issues. Furthermore, it might be helpful for you to see it happen live. And specifically, when we import data, thinking about how important projection systems are, given there's a whole nearly 30-minute supplemental lecture for this workshop where I talk about projection systems. There's a really important step we have to do before we move further in our analysis, and that's that we take all of the data sets we import and make sure they're all in the same projection system that we have specifically selected for this study site. So you already know some of these things because I talked about them last week. But what I'm about to showcase you is importing data, and I've actually imported most of it already, but I'm going to re-import it. And then I'm going to talk through how you might rename that data set, reproject it, and how then you manipulate the display of those layers. And we're going to start with the vector layers because those are in some ways the easiest to work with. And then we'll move on to the raster data sets, which will take us off in a different direction. So this is the first task. All right, you see I have my web browser open. Okay, so hopefully everyone can see this okay. So this is my view of QGIS. And just a quick software note, you probably all saw the message from Claire about the Windows QGIS issue with 3.16.12. To my knowledge, other versions aren't affected by this issue. The issue that happens is if you have 3.16.12 on Windows, you aren't able to load certain plugins. And some of those plugins are actually quite important. So that's an issue. And so hence why if you're on Windows and you are on 3.16.12, you need to upgrade to 3.6.13. Mac users and Linux users, I don't know if there's any similar issue. I haven't certainly had an issue, but let me know if there's any other issues like that pop up, because we want to make sure we catch those early. Okay, so now from last week, we're all familiar with the interface here. And if you're not, it's okay. You're going to see a lot of the interface in action today. So when you download the zip file that I attached in the Google Drive, this will be a slightly different view than what you have, but you have access to all these different folders that I've compiled from all sorts of different runs of this course before. The one file you won't be able to open probably is the workshop exercise .qgz file. This is a project file, and I believe I talked about this briefly last week. But you see how at the moment where my cursor is on the screen, it says untitled project with an asterisk QGIS. This tells me that at the moment what I'm working in, the workspace that I have set up here, is if I try to exit out of this, it's going to prompt me to save this as a project. What a project does is it basically organizes and tells QGIS how to render the different layers that you loaded. you can think of a project file, a .qgz file, as a container for your layers that you're manipulating. And it also contains information about the style. So if you like the color that's been rendered here for this layer here, this bright orange, if you save this as a project and then you reload it, the same styling will appear. So that's really useful in some cases, especially when styling is really important if you have a complex geological map. But critically, I mean, and this just might be the limitations of my knowledge, it's not straightforward to just share a project file directly from a zip file, because this project file has my file paths built into it from my computer. So if you try to open it, you'll probably get an error, and that's fine. So the first thing that we want to load, I'm actually just going to delete a layer real quick, is we want to load some data in. You see I've already done that. But if I turn off some of these layers, just turn these off for now. When you load a fresh instance of QGIS before you've imported anything, you'll notice that in the bottom right corner here, you'll have a button that says EPSG, and then it should say, usually when you first open QGIS, is EPSG 4326. That is WGS84. That is a geographic coordinate system that has not been projected into 2D Cartesian coordinates. And that's sort of like the default GCS that most GIS applications start in. And it's up to you as the user to decide what happens next. So what you'll notice here is that I have consciously gone and actually before I imported any of these data, I included this EPSG, I changed this to EPSG 31977. I just have to drag this over for you to see. This is the Surgas 2000 UTM Zone 17S projection system. You'll notice how well GIS terminology just rolls off the tongue, all these random numbers and letters sort of just stacked against each other. So you have to forgive me if I stumble over my words. This is an appropriate projection system for our area. I will explain why we're using it in a moment. But the important thing is when you're importing data, you've already made this decision. What am I going to be projecting all my data in? And you verify before you go forward with any analysis that all your layers are projected in that projection system. So I can tell you that the layers I have loaded already in the layers dialog, they are projected properly, but there's one layer I asked you to import in the data checklist PDF, which if I pull up here, looks like this. So I tell you to import this layer. This is straight from the internet, straight from Supplemental Lecture 4, the Geodata at Tufts website. So this layer is going to be in a slightly different projection system, and this gives us an opportunity to talk about how we do reprojection. So I've set this up. I have the right project projection system for this exercise put in the corner. And then I want to import this very long name file from this web server. Here it is. It's GIS portal, GIS owners. I mean, if I try to read this out, it'll take forever. I want to add layer to project. All right, there we go. It's loaded properly. If I right click on this and I hit properties, you're going to be doing this a lot. You're going to be inspecting lots of different layers using the properties dialog. Click on properties. Give it a minute. I have a lot running right now, so my computer is going to be slower than usual. So this line is really important where my cursor is. It tells me that it is in EPSG 32717 WGS84 UTM Zone 17S. This is a minor point, but this is a different projection system than our preferred one, the one that I told you, the 31977 Surgas. That one is a locally defined data, as we'll talk about more in a moment. So I want this to match my other layers. I want this number, EPSG 32717, to match the number down here you see in the bottom. So to do that, we have to perform our very first GIS analysis or task, I suppose, and that's reprojection. And this is something you're going to be doing a lot. I have taken care of most of this for you with a lot of the different layers. They're already in the right projection system. but this is the one that I want you to try to reproject. So exit out of that. My computer's going to be very slow today, I see. So in order to do this, first thing you have to recognize, it's a vector layer, right? It's got this sort of vector defined shape with clear boundaries between polygons. And within the properties tab, there's an option to open an attribute table where I can inspect individual attributes. Oh, I'm so sorry. I just checked the chat. So Claire, you can absolutely choose to follow along if you want. My recommendation, I should have led with this, I apologize. My recommendation would be watch as I do, maybe have QGIS open if your computer can handle it and mouse over the buttons, inspect the layers, but like you don't have to be performing this in real time. It's hard enough for me to do it in real time while I'm lecturing. So absolutely no pressure to do it as I speak. I think it would actually be a lot more constructive if you're taking notes to just kind of take notes, watch and learn as you go. You'll have access to the recording to go back and actually, you can pause it then and sort of take out in your own time. I hope it seems like there were quite a few people who wanted that clarified. Okay. Unfortunately, I cannot enlarge the display. This is about as big as my computer. I'm actually on a bigger monitor than I normally am. So unfortunately, I can't address that. And how do we add the layers? So this is something I addressed last week, but I can just highlight that again here. So if I go, I'm just going to remove this layer again. If I go into my file folder under browser, I navigate down to the layer I want to add. In this case, it's this population census shapefile. I can right click on it and I can hit add layer to project, or I can double left click on it. So I double left click on it, it gets loaded. Claire, can you clarify that QGIS is showing fully on the share screen? Sorry, Claire, I can't hear you. I'll just note that, I mean, ideally you're only seeing the GIS screen right now. Maybe you're seeing my face in the corner. Is everyone seeing the GIS screen okay? I can see just one shared screen. Okay. Okay, thank you for that. Yeah. So, okay, sorry, Claire. Yeah, okay, so thank you everyone for being so responsive in the chat, clarifying that. Okay, I just wanted to make sure, since it seemed like there were some issues, I wanted to make sure it wasn't a problem on my end. I can address an earlier question though, finding the right file if you want to try to follow along. So this is laid out in the PDF data checklist that went around. Hopefully everyone can see this PDF file, okay, that I have loaded up here in front of QGIS. It outlines every layer. I give you access to a lot of data. You don't need to load all of it for today. The key ones I've highlighted here, and for the vector files, they're all found under a subfolder called GIS base layer. So if I go back to QGIS, you've downloaded the zip file, you've unzipped it, you've opened it on your computer, and then you can navigate to it using the browser in QGIS. And that on a Mac, for instance, you would use this backslash or home. And in Windows, it should be something similar like this PC or C drive or something like that. You navigate to where you've downloaded that QGIS folder. You get to, in my case, this will look slightly different, but you get to this QGIS file where all the data is stored. And then for these vector layers, it's under GIS base layers. And for this particular one I'm loading here that I want to reproject, unfortunately, all the names are quite similar, but if I expand this a bit, the one I'm looking for ends with Ecuador level 3 population census. This layer, if you read the metadata associated with it, reflects in each of these blocks, these are census blocks that the Ecuadorian government has reported population and demographic figures for. And you can see the quite fine resolution in urban areas, in more rural areas, it's sort of scaled by population. So by loading this in, you get access to all this population data that we're going to use later on. So if everyone's okay with that, let me know if there's any other confusion about how you get that layer in and how you manipulate some of this. But once you do that and you've loaded this layer in, again, we see it here. We go right click on it, click property, left click on property. And again, it's going to take a minute because there's lots of features that it's trying to load. And it says EPSG 32717. So that is what we want to change. And in order to do that, we're going to go to the vector dropdown. So this is going to be a very familiar workflow for pretty much all the other exercises we're going to do. You're going to navigate to the top menu bar up here where there are lots of drop-down tools. And in this case, we're going to go to vector because this is a vector data type. It's a shapefile.shp. Drop down vector, highlight data management tools, and select reproject layer. So very easily named tool, thankfully not a mystery as to what it does. If you click on that, this is what the tool dialog looks like. It's a very simple tool to interact with. And what it allows you to do, you see I have a couple different layers loaded in. It's only picking up on the vector layers. It's one thing to note. These raster layers that start with DEM, those are not showing up as options because this will only allow you to reproject vector layers. And the layer I want to reproject in this case, the nice thing about it is it already tells you what the projection coordinate system is in the brackets next to the layer name. So you see all of these have the right projection system except this layer here. Oh, I clicked on the wrong one. There we go. So with that one selected, this is the input layer, the one that I'm going to perform the operation on. And then the next very simple step is to select which projection system I want this to go into. And in my case, I want it to go into 31977 Surgas 2000 UTM zone 17S. I see someone has raised their hands. There we go. Okay. I see there are two raised hands. Claire, do you think this is something we should handle at the end, at the break, or should I address now? Yeah. Okay. Okay. I just want to get back to a problem I just saw. I'll try to address this during the break, but Electra, I see you're having an issue loading it. Circle back to me at the break and we'll see if there's a problem with your computer because the layers seem to be working right for most other people. So it could be an issue with your distribution or there could be a problem with the data. Either way, we can get it sorted. And then, yeah, another quick answer. Okay. Yeah. Okay. So there's a few questions here. By default, you should have all these CRS options loaded. The thing is going to be when you see this target CRS drop down, I'm clicking here. I've used all these projection systems before, so it has like a recently that I've set. In order to kind of tell QGIS, which projection systems you want to work with, you have to search in the predefined reference system area. So you can access that by clicking this bottom right button here. You can scroll down in the predefined area. And if you search in the filter and you type Surgas, it will come up. It should be there. If it's not there, then something's gone wrong with your QGIS distribution because this is not an external package that needs to be installed. So another example, let's do WGS 84. So even if you're on Windows or Linux, it should pop up. I want to thank also, I really want to thank the people in the chat who are helping their fellow participants. This is really great to see sort of like collaboration going on in real time, because it's a lot of, yeah, there's a lot of questions coming through. So I really appreciate the help, guys. Keep it coming. And then if you have to specify the vector geometry, this one, so this is quite straightforward. I talked about this last week. There are 3 main vector geometry types: point, line, and polygon. If we're looking at this file, these are very obviously polygons. They have a closed geometry, and there are many of them sort of attached to each other. In fact, all of the layers I currently have loaded into my QGIS, all of them are, all the ones that are vector files are polygon files. They have a closed geometry composed of sort of many lines that are all joined together. Yeah. Yep, and thanks for grabbing that, Claire, about the project file. You can't just drag the project file in and load it all automatically. You have to manually add the data. So that's, again, going into browser, dragging and dropping, right-clicking and hitting add layer to project, or double-clicking. It's totally fine, by the way, that we're taking a lot of time with this initial bit. I want to make sure folks can do the basics before I go further. And like I said, whatever we don't finish today, we can revisit next time. So is everyone happy with loading in this GIS portal layer and getting ready to reproject it? Thanks, Megan. Yeah, and don't, again, if you'd like to follow along, that's great, but don't stress too much if you're trying to do everything in real time. I am going to have to move quick at some points, and it's totally okay. It's totally okay if you're having trouble at the moment. For those of you having trouble loading the data, let's circle back at the break. Because yeah, I'm not really sure where some of these errors are coming from, because I've tested this in a few different computers now. Yeah, okay. I'm just going to move on. Don't worry, your questions will be addressed. But I just, yeah, I want to make sure that we get through some of the material, and we'll try to circle back and address these technical issues as we go. Okay, reprojecting. Once I'm happy with the target CRS, the target coordinate reference system, you see the option to run any tool in QGIS. There's a button at the bottom called Run. I could hit this now, and in fact, I will. See, it has a bar that progresses, tells me that it's done. And in this log option here, which is a separate tab, it gives me a lot of different information about what got outputted and where. So I'm going to exit out of this dialog now. And if I go back to my layer dialog, there's a new layer. It looks exactly the same as the old layer critically, because all I've done is reproject this. All I've done is put it into a different, I put it through a different mathematical model that's transformed the geometry of the data slightly, but basically preserved most of the key features. So now that I've done this, you see that this layer is now just called reprojected. And if I mouse over it, or if I right click on it and hit properties, just take a minute because there's lots of data loaded in there. Notice that it has this ridiculously long name that doesn't really correspond to anything real. And that's because when I ran that tool, I left the option open to save as a temporary layer. So if I open the tool again, go to reproject layer, see how it says under reprojected, this is sort of the output step for a tool. It has in sort of grayed out brackets, create temporary layer. Because I didn't put anything in that box and I just hit run, it's going to output this placeholder, basically, that when I exit this project, it will disappear forever. And that's obviously not a good thing. We want to make sure we save that. And you know, by the way, it's temporary because on the right, it has this little gray icon that says temporary scratch layer only. So if you left click on that, it gives you the opportunity to save this file, make sure that it doesn't go away when you exit out of this session. You have a range of options when you want to save this file. There's all sorts of different geometry and format options. In my case, I'm going to keep it a shapefile for now. You need to tell it a permanent location where this is going to be housed. So I'm going to do that very quickly. Nope, that's the wrong place. So I go to QGIS, I go to live demo. This is where I store kind of the scratch layers I'm using. So I'm just giving it a name that I know will make sense to me later. And I hit OK. Great. It says that it's saved this new layer. Now notice the old version hasn't really gone away. So I can get rid of this. I can hit this button at the top here with the little red symbol, or I can right click on it and hit remove layer to remove this from view. And then if I go to my live demo folder and I try to find, the layer I just made. There we go. So notice that when I load in new versions of this data set, it just sort of changes the color randomly. That's an innate feature of ArcGIS and QGIS. Basically, it's just trying to differentiate between the relative layers. This is something you can change and manipulate. So hope everyone's good with that. That was importing and reprojecting. And what for this exercise, you do not have to import and reproject every layer. You just have to import the layers that I mentioned in the data checklist. Make sure you inspect them. You kind of have a general understanding of them, but you don't have to manipulate. Yeah, you don't have to do this for every step. The data I've given you is already reprojected and already in a usable form, unless you're having issues, in which case we'll get to that. Anyone who's raising their hand, if you just drop what you have in the Q&A, that would be easier, because I only have two screens. I can't really manipulate that much information at once. So that's adding data, getting it set up in the layer dialog. And I should note, for anyone who missed last week or it needs their memory jogged, if say, I'm happy that this has now been loaded, but I want to see one of the other layers I made stacked on top. All you have to do is drag a layer on top of another to see it displayed. And you can do that kind of in any order you want. So you see, I can start dragging and dropping these vector layers to show them in different sort of orientations. All right. Yeah, no, I'm happy to show how I saved the layer. So when you have a temporary scratch layer, unfortunately, I've already progressed past that step. Basically, once you have that temporary layer, you click the scratch layer button on the left. It gives you an option then to pick a place in your hard drive where you want to store that file. I'll ask you to just try to do that yourself. There will be a button there. You can also right click on a scratch layer. There'll be an option to say make permanent. And that also will permanently save the file. So, all right, let's move along. Don't worry, we will come back to some of these things. So I'm gonna share my screen again, okay? So the next bit, this is a bit more sort of conceptual than actual work, because we've already kind of addressed this. But I said last week, you need to make sure you've decided on a projection system before you get going. I have already done that for you for this exercise. I've already set out which projection system we're going to use. And I want to walk you through why I chose this particular projection system. So our key criteria, we're working on a particular volcano in a particular part of Ecuador, which is located in South America in the Southern Hemisphere. That's a lot of geographic information. And with any projection system, we want to make sure that we are picking a projection system that is standardized for that region as much as possible. There are, in some cases, very specialized localized projection systems that account for very minute variations in geodetic signals. But more often than not, there are sort of regional level projection systems that you can use for anywhere on Earth. And some of these are quite specific. So we want one that's defined for Latin America broadly. Ideally, it would be one defined for Ecuador. And when you happen to go on, there are a couple places you can go to do this search. One place is the EPSG repository. See a screenshot of an old version of the EPSG repository here. And the EPSG sort of code and websites, these are places where projection systems it's sort of like the reference manual for projection systems, what their names are, who made them, when were they last updated, and then all of their actual geospatial data. So you can go to epsg.io if you want to mess around with this yourself, but you get an option to search a particular area. In this case, I just put in the country of Ecuador, and you see it gave me about 32 possible results that I could work with. I did a lot of experimentation. The one key thing that I wanted was a projected CRS. I wanted one that had gone through the process of going from a geographic to a projected coordinate system. Therefore, it would have units of meters, ideally, and would be in 2D coordinates. So it would be usable for our kind of human scale, map scale observations. And even then, there's still lots of options. So what I decided to settle on was Surgas 2000. And there were a few reasons for this. And this isn't necessarily the right reason for this region of the world. And in fact, if any of you work in or know anyone who works in Latin America or in Ecuador, I would love to know what other projection systems they use, because there probably are other ones I'm not aware of. This was just sort of the one that I found most beneficial for this particular application. Yeah. So the key features of Surgas that I like as a user are that it was recently defined. So it was sort of there was an older version of Surgas that different South American countries have been working on in the mid 20th century, it seems. And then in the mid to late 90s, there was a big meeting among different geodeticists across South America. And this projection system was sort of standardized for the continent at that meeting. It has a very good accuracy for a projection system, which is also very helpful. And it fits within our bounds of our operating area. You see that Surgas 2000 is also called UTM Zone 17S. UTM is an acronym very common in projection systems. It stands for Universal Transverse Mercator. And if you remember last week, I talked about the Mercator projection system. This is one of those kind of standard projection systems that has some issues associated with it that does work under certain applications. There's a different version of the Mercator projection system called a transverse Mercator. And it just so happens that if you divide the world into very thin longitudinal slices, the transverse Mercator projection method actually works really well for preserving regional areas, shapes, and angles if you kind of limit it longitudinally. So one common projection system to look for if you're starting a project and you're trying to figure out where you need to go to set up a projection system, which one should I start with? Look up what UTM zone your area corresponds to. And that's a good starting point, because a lot of different projection systems are defined for UTM zones, and a lot of geodetic data and geospatial data in the US is defined, in North America generally, is defined using UTM zones. So in this case, we happen to be in 17S, the S for the Southern Hemisphere, and Ecuador being right on the equator means that part of the country is not covered by the southern bit, and you might need to go to the Northern Hemisphere bit. If we go real quick, I'm going to go back to QGIS for a moment. If I go back and I select this area, there's something really important I want you to note. And that's that our operating area here, once you sort of open this project properties, the CRS dialog, the sort of effective area for a given projection system is given in red here. And you see this red box as I'm dragging through it. This red box is where it's known to have that meter accuracy and known to preserve angles very well. Whereas this purple area here actually represents our data. And in some cases, the overall sort of trend of our data actually extends beyond the accepted tolerance for this projection system. And this is something that stresses a lot of people out. You know, you may say, oh my gosh, how do I find a projection system that actually encompasses my whole area? Especially say if your particular layer doesn't obey national boundaries, how do you select the right projection system? My answer to that sort of concern would be, just keep in mind that outside this red box, if you have data, ideally you want all your data fitting in the red box. You want the purple box and red box to line up as much as possible. But where that's not always possible, just given the nature of the problems we deal with, particularly with volcanoes that don't obey national boundaries or longitudinal boundaries, as long as you are not absurdly outside the sort of boundary of this box, your error is going to go up. The distortion is going to be greater towards the east in this case and towards the north, the further away you get from this red box. But it's only really once you start to get significantly away. And I know that's not very quantitative, but it's something you have to get a feel for based on your data. And in this case, it's not really a problem. We're mainly, even though some of our layers extend out further, we're mainly concerned in this area of Ecuador, so we're fine for most of our analyses. And thus, this is a suitable projection system. Alternatively, you could use, if Ecuador has a national grid, we could use that. This is just the one I selected. And the reason that this is also important is because a transverse Mercator projection for a particular slice of longitude, you can see how much, when it's, I think in this case, it's centered on the poles, how much it distorts the rest of the globe. So for instance, if I was trying to compare Guagua Pichincha to another volcano, that would not be ideal because you know, if I tried to compare Guagua Pichincha to say La Palma in the Canaries, the degree of distortion using that same projection system would be too great to tolerate and would vastly throw off my error. So given that we're working with a UTM type projection system, we have to make sure we're staying local with the data. I have a great question in the chat that kind of sums up all this. The choice of the projection affects all your results, and someone next to you could potentially have could potentially use a different projection system for the same kind of data and end up with a slightly different result. It could even in some cases be significant depending on how well you've treated the data and how well you're applying the projection system. But if everything else is the same, you could end up with different answers. And the key thing is recognizing that maps by their nature distort reality. You are, by the fact that you're making a 2D representation of a complex 3D object, the Earth, no matter what, you're going to have error, uncertainty, and essentially your map is just a model. That's all it is a model of the Earth's surface. So your choice of projection system, while it seems daunting, it's really a minor line in your overall error calculation. It's going to be one of the smaller sources of error usually if you've done it right. But just because you and a colleague maybe use different projection systems, you end up with different answers. I honestly, I wouldn't say either of you is right and the other's wrong. It really comes down to, did you choose the right kind of projection system for your area? If your colleague chose, a UTM zone, but you're working in multiple countries that span multiple longitudinal zones, then that's probably, your colleague is probably in the wrong there because you want to make sure that you're representing a wider regional projection system potentially. But if you both chosen suitable projection systems for the problem you're facing, that's all you can do. And you just have to accept the fact that because a map is just a model of data that can vary depending on your choices as a user. You just have to tolerate that uncertainty. I know that might seem weird because maps seem so static and so kind of true just to look at them, but they're not. You can see here just like the way the difference between the Mercator projections. One isn't more right than the other. We know Central America isn't actually that big, but in this case, this map for what it was meant for is doing it right in the Greenwich mean time longitudinal zone here. This UTM is working for the purpose that it was designed for, as was this one. Greenland is also not the size of Africa. So it's just using the right projection in the right area at the right time. I noticed that we're hitting 1 o'clock now. this is probably a good time to break. I know there were lots of questions in the chat, some technical issues potentially. So what I'm going to suggest is that we break for maybe 10 minutes, if that's okay. So we'll reconvene at 13:08 GMT, 1:08 GMT. So get up, stretch your legs, or if you have questions, I'm going to start going through them in the Q&A and the chat. So that sound good, Claire?
Great to me.
Yeah, thank you for fielding all the questions that we've been getting. So see you all in 9 to 10 minutes. Okay, so. Okay. All right, I see, yeah. Okay, so I'm gonna start with the Q&A. I know people have been posting questions in the chat. If you have a burning question that hasn't been addressed yet, even if you asked it a while ago, please post it in the Q&A. It makes it easier for Claire and I to manage. I see Ben Ireland has a question. When I imported the vector layers, they all say invalid projection. That's obviously an issue. So my first question, Ben, will be whether you are using the Google Drive version of the zip file or whether you download it directly from GitHub. If you and the reason I ask, and this is an important note for anyone who's still with us at the moment, is for some reason when you download a zip file from GitHub, GitHub does something weird to the encoding for a lot of the layers, and it makes it so when you try to open them in QGIS, then QGIS can't understand them. That is a flaw, but the real way to do this is to use actual Git command line. That actually avoids this issue, but I don't expect you all to do that at this stage. So I've made all the data available as a zip file on the Google Drive. That has been tested on multiple computers, and I haven't run into any issues with anyone importing it. But that being said, Ben, if you are using the Google Drive version of the zip file and you're getting invalid projection, I would ask, are the layers showing up? And if they are, what sort of CRS options do you have when you open the CRS, the project CRS window? Like, can you see 31977 and all that? Because if you can't, then we need to figure out a way to make sure you have access to all the projection systems. So the kind of a multi-tiered answer there, Ben. So if you can, I'm going to mark that as done for now. If you could get back to me and let me know via Q&A if your answers to that, that would be helpful.
There was someone who asked anonymously about the where to find the shape files. So if you are still having trouble, just send another message, but hopefully I've directed you to the GitHub or the Google Drive and you can find what you need for that.
Mm-hmm. Yeah, thanks for that. And I saw a more general question, like, how are these shape files made? And that's a very good question that gets to what we're going to be doing in a bit. So these shape files the actual process of making them is very interesting and could be like a whole PhD in and of itself. If you're, for instance, working on volcanic landforms, you could make these shape files from scratch based on field observations and then bring it into QGIS and then define them yourself. In this case, these are shape files in most parts that either we're going to make. Most of the time, though, like these national level Ecuadorian governmental data files were put together by the Ecuadorian census. And it's a bit, to some degree, it's a bit beyond my pay grade to know exactly how they define the boundaries between different census blocks. That cuts to, how governments actually know where boundaries are, because they are just arbitrary lines on a map. So I can't really speak to that in great detail. But yeah, that's a very good question. Thankfully, there are lots of data sources that give us access to these kinds of files. And if you don't know what those data sources are, I encourage you to watch supplemental lecture 4, which went up last week. I talked through different data sources there and the places I went to get this data.
So I guess I'll take this. How do you access these shape files? Are they open access? So specifically for this course, the files can be accessed through the GitHub or the Google Drive. But generally, I think Nick provided a whole bunch of resources last week that are open access. Most of them you need to create an account in order to download them. But there's a really nice list of resources in the second PDF guide, which gives you basically every website, which websites you need an account for, and which information you can get from which website. So if you wanted to, access these shapefiles for somewhere that isn't the volcano we're looking at right now, that would be your first port of call to figure out where you might go. Because I totally understand that it can be overwhelming, the amount of sources there are and the amount of different information you might want to find. Oh yeah, great. So Nick has that on screen now to show you.
Yeah, so this is from the session 2 guide on the GitHub, and it was also sent around last week via email. And yeah, I mean, this is probably just scratching the surface for all the different places you could go to get data. You, for this course, do not have to go and get the data. I have already gotten it for you, but for your own projects, this is where you would go to get this kind of data. All right. And then Anthony Lemur, can I check the GIS portal shape is just Ecuador country and pop census together? Good question. So in terms of what it is, it's not actually the country layer overlaid with like a bunch of lines that define the census blocks. I'll actually show you how this works. And I'm going to talk through different vector geometry types in a bit, but if I grab the right tool, it always takes me a minute to find the tool I'm looking for. And this is someone who has been doing this for ages. So notice what I just did here, just very quickly. I use this, what's called the identify tool, which I'll talk a bit more about in future weeks. It turns my cursor into a little, basically magnifying glass. It lets me click on different features and identify, different aspects of them. And I said this was a vector layer. It's made up of a bunch of different polygons that are nested against each other. And each of these polygons has a closed geometry that makes it a distinct feature from all the other polygons in that layer. And then all the polygons themselves are sort of just broadly grouped together in this layer. They're basically just individual components all organized within the same file. I could have a polygon of Venezuela, hundreds of miles away in this layer still. They don't have to all be next to each other. And in fact, we're going to make some of these polygon files today. So you'll actually see under the hood how we actually make this. So to your question about this GIS portal layer, which is the red layer shown here on the screen, when I use the identify tool and I click on a particular one of these blobs, these census blocks, notice how it itself and it alone gets highlighted in red. And that's because in this case, you see in the identify results, it tells me it's object ID 793. It's the Gonzalo Diaz de Pineda, sort of this particular census block. That's the name given to it. And so rather than this being a country shapefile with just lines drawn on it to indicate the different population census blocks, this is a dynamic block of each of these blocks has hundreds of different data points, which is why it might take your computer a minute to load. And this is demographic data, hundreds and hundreds of different data points about how many people live here, their age, their sex, their gender identity, all sorts of that kind of stuff. So a vector data model is actually quite complicated. And Anthony, you've kind of hit on it there. And you'll have an opportunity to explore this yourself in a short time. So thanks for anticipating that.
Okay, I think you're all good in the chat, Nick.
Okay.
So open ground for any other questions that want to come in.
Yeah. So yeah, if you do have any like burning questions, again, post in the Q&A version, because the chat gets so filled up with you all helping each other, which again, I'm loving seeing how many of you are helping each other. Thank you, Claire. Yeah, Claire Harnet's helping a lot. I see lots of other people chipping in. Yeah.
I like this question from Claire. After we click on the magnifying icon, how do we get away from it?
Good question. And so yeah, you notice once you've done that, you try to click away. It's trapping you. the way to navigate back is to go over, if you see where my cursor is moving, I'm moving towards the left of all these different icons. There's a hand icon. If I click that, this is my pan tool. And you see it's a little glove. And when I click down on the left mouse, it lets me drag. That's the easiest way to escape, is to select the pan tool. Man, you guys are anticipating all this stuff before I even get to it. This is great. This is going to save me a lot of time. Another option, yeah, we'll just stick to the pan tool for now. Cool. All right.
A question in the Q&A, Nick. How do you show
yeah.
the overview window?
I talked about this last week, and if you weren't here for that, totally fine. The way to do this, very simple. You go to View, scroll down to Panels, which should be near the bottom in Windows too, I believe. And then there's an Overview option here. If you left click it, there should be a check mark that appears, and you'll see this box appear at the bottom. Initially, you'll have nothing in there. The way to add things is to right click on them and hit Show an Overview. That's sort of the way that you approach that. So you notice if I click off that, the country goes away. I right click again, I hit Show an Overview. And then the nice thing is if I zoom in, notice how there's a red box there that renders and shows me where I am in the view. So I find this very helpful, especially because we're going to be working at very high resolution in some of these maps. It's great to know where you are. Good question.
So I'll take another couple of questions from Q&A.
These will be the last two, but yeah.
yeah, great. So Elliot says he's loaded in all of the GIS portal files and they all seem to need reprojecting. Is this correct?
Good. Yes, good, Elliot. If you load in all the GIS portal files, which I do suggest you try, you'll notice they all are not in 31977. Those are the raw files from the Tufts data source that I talked about in supplemental lecture 4 and is referenced in the guide. So if you bring those in and you wanted to use those layers yourself, before you do anything, you need to reproject them in the same projection system the rest of the layers are using. The whole project is meant to use. The ones, so if we go back and we look, I know for some of you it might be small on your screen, but if I go to the GIS base layers folder, notice that there are layers that start with GIS portal, and then there are those that start with sort of short acronyms in all lowercase. The ones that are all lowercase are ones I made and reprojected. That's my naming scheme. I use underscores and lowercase. That's my preference for naming. The ones that begin with GIS portal are all straight from the internet, fresh from the internet. So they require some work before you get to them. So good picking up on that. So if you want to use them, yeah, reproject them yourself. And I had to do this dozens of times for this project. So.
And a final question before we get back to it. When I think this came up in the chat a couple of times actually, when they changed the projection of the project, they get different views. So only the purple box and not the red box over the map. How do you get this red box to show up?
That's a good question, because obviously you can see by default for me, if you're watching along right now, Karis, that the red box is showing up whichever projection system I click. If I click a particular Indonesian one or one in Ecuador, I'm trying to think what would be the option. That might have to be one I circle back on.
Yeah, perhaps some people in the chat might be able to give Karis some advice there, because I think some people were having this problem and overcame it. So maybe somebody else.
What I will drop in the chat is, so you notice what I just did, and what I'm doing at the moment is I click Help at the bottom of a particular window. If ever you're working with a tool or a particular window in QGIS and you have no idea what's going on, then if you click on Help, it'll take you to the area of the QGIS documentation where they explain it, and they have very rich level of detail there. There might be an answer there as to why the red isn't showing up. I guess you just want to make sure you have both selected. And if anyone in the chat can help and figure out why Karis might be having that issue, that would be very helpful. But for now, I'm going to have to leave that and we'll move on. So yeah, thanks everyone. I hope you had a good break. I mean, I know some of you have been back for a few minutes now, but we're going to keep moving on. And the next step, we're actually going to be doing some analysis. So I'm going to actually click off all these layers. I have to just load up. All right. I'm a little ahead of myself. So we've loaded our layers. We've reprojected the ones that need reprojecting. Thankfully, all the ones that are named in lowercase with underscores, those are ones I made that are in the proper projection system, you'll notice. So once you have those loaded in, and you're happy, you've also imported the raster layers, by the way. I know we haven't talked about them, but if you go further down the data checklist, you should load in those 2 raster layers as well. You'll also note that on the data checklist, there are some geology layers that I asked you to load in. And you'll notice when you try initially, one of them will load, it'll be a map that's sort of distorted, and the other will just sort of not really appear. And this cuts to the heart of a really important problem for geologists, and that's how do we take images, things like an old map that someone had, and how do we bring it into GIS and actually use the data? This whole area of concern is called georeferencing. So georeferencing is the assignment of real-world coordinates to an unreferenced raster file. And if you think about any PNG, JPEG, or TIFF file, sort of common image distribution files, any figure from a paper, any sort of scan of a PhD thesis or something like that, those scans preserve data in pixels that are colored according to the color the user defined. And in order to make that data usable in a spatial place, you need to essentially take that image file. And if we're thinking about this conceptually, the operation you're going to perform is you're going to put pins in that image file on landmarks you can verify on an actually spatially referenced file. So for instance, I give you data sets that show you the topography of Ecuador. You're going to take the sort of shared features that you can observe in this geological map. You're going to basically stick a pin through that map and then stretch it to fit down to that feature on the overlying topography that we know is spatially referenced and we have a known accuracy for. If you add enough of those pins, you're going to distort the image quite a bit from its original nice, even aspect ratio. But at the end, you've essentially draped this image over some sort of topography or other feature. And you've made the underlying data usable in a spatial context. So the topic of georeferencing is a very, it's one of those things that when you start in GIS, it's one of the first things you often have to do. And it's also kind of the first tricky thing you have to do. So when I show you this today, I know some of you are going to be like, oh my God, how do I do this? Don't stress too much about it. You can come back and watch this bit of the video, or really what you have to do is you have to go by trial and error. You have to learn how to do this yourself, because like a lot of things, it's more of an art than a science. You have to get a feel for how good georeferencing is done and what a properly georeferenced map looks like just by doing. So watch me do it, take some notes, try it a bit yourself, and then revisit this as you go and try to repeat this in your own time. Try to georeference the map from scratch like I'm going to try to do. There are lots of choices going into georeferencing as well, but I'll get to that. So what we're going to do, and this is going to set us up for this whole problem that this question we're trying to answer. Remember, we're trying to figure out what the risk of hazard exposure are to different populations around Guagua Pichincha near Quito. And it just so happens you dig around the internet, you say, okay, how do I find this type of information if you don't have access to it through your research or something? And I, in setting up this exercise, found this wonderful poster that was presented at a conference in 2019 by an Ecuadorian team on a new hazard map for Guagua Pichincha. And it includes very rich underlying data, including pyroclastic flow scenarios, so modeled extensive pyroclastic flows for different eruption scenarios. Guagua Pichincha has had a range of different, I think VEI 2 to 5 eruptions. I could be wrong on that, but I believe it's VEI 2 to 5. And so the 10th century Guagua Pichincha eruption, which was historically recorded and has been described geologically, this eruption is the biggest that we know on modern historic record. And this is the one, we'd be most concerned about if there were to be an eruption. This is the one that could impact the largest area. You also note there's an area of Quito that's sort of marked out in black. And if you're not familiar with Ecuador, Quito is the capital of Ecuador. It's the second largest city, I believe, after Guayaquil. It's a very dense city. It's located, as you see, right on the sort of eastern flank of the volcano, where the crater opens towards the west. And the other bit of information on here are secondary lahars. This is critical, right? Because this bit here, these are the pyroclastic density currents in the initial eruption that we see geological evidence for where they've fallen. And it seems like this ridge line does a good job protecting against that initial pyroclastic outburst. But there's significant geological evidence from the 10th century eruption of secondary lahars that went down the eastern flank and went into Quito. That's bad, right? Because those would be the things that post-eruption by a rainstorm or by a landslide or another event could be mobilized and would obviously be a huge threat to human life. So the secondary lahars are very important, as are the initial pyroclastic density currents. And then these lines here, these isopachs, 30 and 90 millimeter respectively, these show where the relative thickness of ashfall is going to be, again, constrained by geological evidence in this case. So this map is a final product, right? Someone went to all the trouble of gathering this field data, bringing in the QGIS, making these layers, running these models, and they presented it. Our problem, and this is the problem you're often confronted with GIS, is someone has asked you to take this map and do something with it. Because in this case, I actually haven't emailed the authors, so at some point I probably should. But for the purposes of this exercise, I honestly didn't want to know whether they had the original data files. But in a lot of these cases, you're going to be presented with some sort of spatial data set, a map or something. And unless it's from a really high quality publisher, like say the British Geological Survey or a National Geological Survey, where they may have the underlying shape files and geospatial data as a product that you can download, a lot of the times you're going to have to do the manual work of bringing this thing into GIS. And in our case, we know that this was in GIS at some point. In fact, I'm 99% positive this was made in ArcMap. It looks just like it was made in ArcGIS just by the aesthetics of it, which is not a bad thing. It's just I can sort of pick up on that. And with that, that means that our task is a bit easier because they've already done a lot of the GIS groundwork. We can match features pretty easily. So what we're going to be doing when we're georeferencing is we're going to pick topographic and sort of any other sort of features, including sort of watersheds and whatnot. And we're going to try to match the locations on the image to control points on the ground where we have known data for. So once we do this, this sets us up to then extract the data from this map. But we can't do that until we know where this map physically is on the surface of the Earth. So I see there were no questions. I'm hoping that means that you were all listening and rapt attention as I described this. And now I'm going to open QGIS and I'm going to show you how you do this. I should note that this used to be a lot more difficult than QGIS, but they've really improved it since I started using Q about 4 years ago. The georeferencing algorithm is a lot better than it used to be. So in previous years, I would have probably recommended you only use ARC for this, but I think Q potentially has ARC beat even in terms of how the georeferencing works. That's just my opinion. But all right. Okay. So in order to georeference, going back to the data checklist, what we need is our raw ungeoreferenced geological map. In the download zip file, there is an ungeoreferenced geological map called gphazardmap.jpg. The JPEG is the key thing. JPEG should let you know that that is just an image file, right? There is no sort of geospatial data associated with that. I also have the final version, georeference version of the map there. You can choose to download that and see what that looks like. I'm not going to import that for now. I'm going to save that until I've done this exercise. But what I'm going to do is import this, and then I'm going to show you how you go about georeferencing it. So what I'm going to need before I even do that is I'm going to need these two layers, the DEM merge and the DEM hillshade. So if I go here, this is roughly my area of Guagua Pichincha. The difference between these two layers. So these layers are shuttle radar topography mission data files. These are DEMs or digital elevation models. And they are one of the most common topographic data sets people use to represent Earth's topography. In this case, these are kind of the standard output, standard in pretty much every way, especially in resolution. They're 1 arc second, which I'm not going to try. Off the top of my head, I can't remember whether that's 10 or 30 meter resolution, but it's good enough for regional level analyses, probably not good enough for really fine scale analyses of like an individual outcrop or something like that. For that, you need a lot higher resolution versions, yeah. But 1 arc second, SRTM, digital elevation models, or DEMs, so a lot of different acronyms there. The raw data that comes out requires a lot of pre-processing to get it into QGIS, and I've done some of that for you. This includes things like fixing holes in the layers and pre-projecting them, merging different DEMs to get like a cohesive product that covers the whole area rather than individual tiles. And then finally, the final step to make this bit easier for you is I remade the DEM to a different version of a raster file called a hillshade. And the way you do this is once you click on the raster drop down, it's quite straightforward actually. I say straightforward and then I can't remember exactly where they put the box. Yeah, so if you go to the raster dropdown under analysis, there should be a tool called hillshade. If for whatever reason you can't find it there, if you go to the processing toolbox, this gear, and you type in hillshade in the search bar, you'll see it pop up. What this particular tool lets you do is it lets you treat your raster layer like there's a sun that, at a particular angle with respect to the surface, and lets you reproject the layer, sort of revisualize the layer as if the sun is casting shadows over the terrain. This is really helpful in general for showing topographic features that might not be obvious just from sort of the raw DEM, especially when it's in black and white. But we're going to do a lot more with the symbolizing of this later. You can see, I mean, the features are a lot more subtle on this version, whereas in the hillshade, it's a lot more obvious what's going on. Note that this isn't actually 3D. This is just sort of a trick of this, essentially an optical illusion that we're forcing the software to render for us to make it easier. So in order to georeference, we again use this raster dropdown and we go to georeferencer. That opens a window with lots of different options, and I'll take you through them in turn. The first thing you need to do is tell it what you want to georeference. So that is this box here that says open raster. It has a checkerboard pattern. If I click on that, notice I'm already there in my files, but I'll make sure I drill down. So here I am in the QGIS folder. I double click on geology, and then I look for gphazard.jpg. And here it is. So if you tried to load this directly through the browser, you either get an error or you'd see nothing even after it loaded. And that's because, again, there's no spatial data. So QGIS doesn't know what to do with it. It might try to import it, but it's not going to know where to put it or how big it's supposed to be. It's just an image file with no underlying spatial metadata. So, and that's where you come in. Before you do anything, you need to make sure that you get the settings set up right. And I just saw a question about how you get the georeferencer window. Okay, again, very straightforward. And this is again on a Mac computer, you go to raster, drop down georeferencer right here. It's the third one down, has a little grid icon. If you don't see it there, let me see. It's not in processing toolbox. The other place you'll find it is under plugins, I believe, at least it used to be, because it actually used to be a standalone plugin back in the day. Installed. Have they now? Okay, because this used to be the other place you could find it, but I don't see it here anymore. So I assume that it's now just built in. So hopefully you see that when you click down here. And if not, yeah, follow up, because it should be a built-in component of QGIS. So before we start actually putting down control points and georeferencing this, we need to make sure that we're happy with the settings for georeferencing, because there's lots of different ways you can manipulate this. First thing to note you want to make sure the first question it asks is for you to specify the transformation type. This is just my rule of thumb, unless you have a reason to do so otherwise, or you're looking to optimize, unless those two criteria fit you, you just want to use thin plate spline. It's a good algorithm. It usually does a good job fitting different points and minimizing error. It doesn't wildly distort the shape too much. The other algorithms are they work for particular purposes, and perhaps are much better at smaller scale in some cases. Something like a linear transformation is going to be pretty error prone, so I would tend to warn you against that. But each of these has their uses. Generally, I find thin plate spline for this kind of geological application works pretty well, but you might want to experiment if you have your own data sets you want to georeference. And I just saw, just real quick from Lauren, if you want to import this data set, when you open the georeferencer, you click the very first button, the checkerboard icon, and that will open a folder to your hard drive. And that's where you'll load in the GP hazard map. You just double click it and it'll load right in. So thin plate spline, nearest neighbor, again, you're welcome to try to change this. This again, just sort of, if gaps are made when it stretches, it'll resample the pixel value. Nearest neighbor is a good starting point. You're welcome to experiment with the other ones, but this is the one I'm going to use. The target reference system, again, you guys should be familiar with this at this point. We're going to use Surgas 2000, so 31977, and you can click on this icon here to select it if you can't find it otherwise. Yeah. So then output settings, this is going to be something for you. You're going to decide where you want this to output on your machine. So if I go to QGIS, I go to live demo, GeoRef VMSG. There we go. The default output file type is going to be a TIFF, a GeoTIFF file. The nice thing about TIFF file formats is that obviously they can be image file formats that are just static, don't have any spatial information. But the TIFF file format is flexible enough to allow for geospatial data to be built in there. So there are TIFFs and then there are GeoTIFFs. Very helpful format. It means that if you're storing your images as TIFF files, it sometimes makes it easier to import them. But JPEGs and PNGs work just as fine. Just a kind of a computer geek note. Compression, unless you have a reason to do so otherwise, just put LZW. It works well. I don't feel the need to explain it too much at this point. And then the rest of these, again, these will have particular applications. I haven't had a need to use them, but you can click, again, you can click the help icon here and it'll explain each option in detail. The final thing that you want to make sure that you save are the reports. You want to make sure that you have a PDF version of the map as it is finally projected, saved as kind of a backup copy in case you have to go back and figure out what you did and how you did it. And the PDF report is a great feature because what it means when you save this is it actually will save your errors for you. And that's huge because this is one of your key sources of error when you're going to determine how much uncertainty there is in your estimates on how these lahars are going to impact the city. You want to know how the georeferencing error factors into that. We already have projection system error. We know that's a meter. And we also have, in this case, we would also have georeferencing error. So you want to make sure you save that. Like double clicking the ellipsis here. Again, it takes me to a place in my folder where I could say, GeoRef VMSG error. There you go. And it's going to save as a PDF file and then have that done. For the Q&A question that just came up, well, let's address that at the end. That's a much bigger topic. So we'll leave that there for now, but thank you for that. We'll come back to that. All right. Now notice how my QGIS is an annoying thing, hides the window every time I hit OK. So now that we've done that, we are going to, we're now going to place our first control point. The procedure for doing this, everyone kind of has a different way they'd like to do it. My tips, if you remember from the presentation, were that you primarily use sort of topographic features that are verifiable on both places. Road intersections are good, and I give you access to a road layer if you wanted to try that. In this case, that isn't actually that useful because our base map, the one we want to georeference, doesn't have roads. But often on like older geological maps, someone will have noted, I-87 or something snakes around the bend here. And if you load in a road layer, then you can sort of use that as a control point. The one control point I would urge against are town names. And there's a few reasons. One is that like when it's a spatially large town with a big spatial footprint, there's, you don't actually know exactly when on the map, the thing you're projecting, if it's just a dot that says Quito, when you zoom in really far, how do you know where on Quito the original base map placed that dot? You don't really know the scale that marker is sort of referring to. And something I've run into a lot in doing this type of work in India is that between different provinces, there'll be many similar names for different towns that sort of repeat across different regions. And so just because you're seeing the city of Mahabaleshwar or something in this particular area, there actually could be multiple Mahabaleshwars, and therefore you can't be confident that that's a good control point then, right? Because just because you can put the pin on the base map doesn't mean you can exactly find where that is on sort of the verifiable spatial data. That being said, if you have really good quality data, perhaps, for some of these things, perhaps you can use other data sets. But for me, the go-to is always topography. Topography does change, but providing that we're working in sort of the same time frame of relatively, within a human lifetime or so, we can ideally use some of the same topographic features. And where this doesn't apply, you're just going to have to be creative about what sort of features you can verify on this map versus the base map. So that's my general advice. Here we're going to use topography because it just so happens that to make their map, I think they use the same SRTM that I'm using, which makes georeferencing this very easy. So what you're going to do, and it does this by default, is it selects this icon that has a yellow square in the corner. And if you mouse over this, the name of this tool is add point. So your cursor becomes a little crosshair. And if you use the scroll wheel on your mouse, or you can use these zoom in windows here. Here, I'll zoom out a bit. This feature here is a really prominent feature that stands out really well against the surrounding topography. This is where I want to place my first control point. Now, I can zoom as far as I want. You notice it starts to get pretty pixelated as I get to really high resolution. Maybe I just want to make sure I'm dead center in the middle of this, what looks like kind of a river valley with really steep sides, escarpment of some kind. So I'm just going to place my cursor right in the middle here, and I'm going to left click to place my first control point. And when I do this, a menu should come up. There we go. It hides elsewhere on my computer. When you click, it's going to come up and say enter map coordinates. So this is where if you have a control point like in QGIS already that you have known coordinates for, you could just manually type them in here. If you know where exactly this particular feature is you're going to georeference. In the really nice feature about Q's new version of the georeferencer algorithm is that rather than type this in manually, you can hit from map canvas, and this will allow you to actually interact with your actual live map and place the point interactively. So I'll show you what I mean by that. If I left click, now my cursor in this view now becomes a crosshair, which lets me know that if I left click right now, it's going to place that point. So I want to make sure that I left click in the right place. I can back it out if I make a mistake. In fact, if I just click here, I can say, no, that's not right. I need to actually find this feature. And actually, let's just do that again. Remember what we're looking for. We put the point right here in the middle of this steep escarpment on the edge, just before we get to the city of Quito itself. So if I zoom back out, the ridge that's sort of separating us from the craters there's the escarpment. Okay, so I feel pretty confident that this is sort of the volcanic area here. You notice the way I did the hill shade, it's not perfect. There are these sort of valleys that are kind of blobby and infilled. This is just a feature of the algorithm not really knowing what to do with the angle of the sun that I gave it. But already, starting from really far out, it might be hard, but I already know where I want to go here because I've done this many times. Quito sits in this nice valley here, and you can even see how Quito itself is built on lots of these potentially secondary lahars that are quite dangerous potentially. And we see a nice feature that really helps us figure out where we are. We see this sort of kink band that sort of comes in here, and we see that sort of sharp escarpment valley there. And I can verify that that's what we have here. See, we have the one secondary lahar goes through this kink valley here, steep valley. All right, I know where I am. So I go back, my mouse is still a cursor. So I said I'd place it right in the dead center. This is about as good a resolution as I can get. So if I click that, I feel pretty good about that. I hit OK, and now a red dot appears. So crucially, so what data comes out once you place a control point is it tells you in the source file what the coordinates are for your X and Y. And in this case, these are ungeoreferenced. These are just pixel values. So which column and row of pixels did you place this in? For your destination, these are the actual coordinates in whatever map unit. In this case, we're using a projected coordinate system that has units in meters. So this is an easting and northing value given in Surgas 2000 projection. And then this is where your error is. And notice at the moment, with one control point, unsurprisingly, we have no error. That's because basically all we've done is we've put a control point in, and this map has essentially shifted to just center on that new feature that we've added. You cannot stop georeferencing here. You have to do, bare minimum, I would say you have to do 5 points. Ideally, you would do 10 plus points. You don't want to overfit. That's going to introduce errors, but anywhere from 5 to 10, maybe even 12 points, depending on the complexity of your map. I did as many as 15 or 20 for some gigantic maps I had to georeference. So it's really your preference and what your workflow is. But you're going to need to do many of these control points. And so you're going to have to start identifying lots of sort of variable topographic features. And the other thing is the spatial sampling. This is the other key thing with georeferencing. You have to do many points. You have to do a handful. You have to do anywhere from 5 to 15 probably. And you have to spread them out over a wide area. If we just were to georeference on the eastern bit here, where we have these really steep valleys, that might be easier. But what we've essentially done is we've only stretched and warped the bit of the map, of the base map, that is kind of in the region we place the control points. The western part of this map would be completely unconstrained. We would have no idea where it actually is supposed to fit because we haven't actually told Q where it's supposed to go. If you imagine us warping the east side and then leaving the west the same, there could be a lot of drift if we don't spread these points out. So you're going to want to spread this out. I would say aim to have an even number in different north, east, southwest, and central quadrants. So hence why 5 to 15 is a good rule of thumb. Bare minimum of 5 means you get north, east, south, west covered, and 1 in the center somewhere. Up to 15 means you could do triplicates, in each of those quadrants. So divide this up and have a go with it however you so choose. But as you add points, you'll see the error, the relative error in pixels come up. And given that we know how big our pixels are, because we can work out how big our pixels are in meters, given we're using a projected coordinate system, this allows us to back out our actual error in georeferencing. So I could start placing these points now. I think for thin plate spline, you need to have a minimum of 3, I think, to actually start getting error. So for instance, let's see if I can just place 1 or 2 more. And you see, this is going to take some time, right? I can't rush and do this because I need to make sure I'm happy with what I'm seeing. I think, yeah, okay, I'm happy with that. So I think near this town of Mindao, there's this really steep ridge. Again, you see, I really like using ridges because they're very prominent, they're very easy to see. If I go where this notch is in the ridge here, where it sort of wiggles, place that as my control point. think I can verify that, is this. Okay, so now I have one red point there, one there. Let's try to get one over out west. Let's just see if there's anything I can verify out there. The western bit I found the most challenging because the topography is not very distinct out there. But let's see, maybe we could pick out one of these. I'm sure some of you are looking at home. You're like, no, Nick, there's one that's so obvious. Why aren't you going there? It's like, I apologize if I'm missing something obvious. I think I see some of these. Yeah, they kind of zigzaggy. Yeah, I feel pretty confident that that's what we're looking at there. Some other sharp bits. Yeah, okay, cool. So the third one up, let's try that, see if I can identify that. See, you might see that I'm gonna have to make a choice here, perhaps not be precise, is super precise, but I can see there's these sort of steep escarpments here. If I just sort of generally place this in the area. There we go. I'm starting to get a residual now, and this means that the map is actually physically being warped to fit the topography that I know was gathered by satellites and has a defined spatial definition. So I want to do this a bunch more times. I want to get these residuals as small as I can. And notice, I mean, these are pretty small residuals. That's what we're going for. So you want to do that many more times. When you're done, you're going to hit this play button here, this triangle called Start Georeferencing. And when it does that, it's going to create the georeference geotiff file. It's going to go to the place in the hard drive that you set up in the transformation settings here, the output raster. And then the report is going to be generated in the place you told it to go. So thankfully, I've already done all this for you. So I'm gonna save. And the other nice thing is when you leave, you can save the actual points you put down as their own point shape file that you could then check later. You know, if you're really concerned that there's been some error early on that affected your analyses, you could load that point layer in into your main map canvas and compare it to other data sets you have and say, oh no, I did a bad job georeferencing. I need to fix that. In this case, I don't need to do that here. So I have this. If I go to browser, I explore the different layers we have under geology, and then I believe this, the georeference version of the map. So if I right click on this, hit properties, compared to the JPEG, first of all, notice the TIFF file, it has a CRS, it has a projected coordinate system. It tells me the unit that it's in, the width, the height, and it gives me a lot of information about the underlying data, which is amazing, very helpful. Notice that compared to the static map, there's this warping that has happened on this eastern bit. And this is, again, because the map, the image file itself has been shaped to kind of fit the topography. Now that I've done this, this is a huge step, by the way. If you manage to georeference this and get something kind of similar to what I have here, pat yourself on the back, because this is one of those initial GIS tasks that throws beginners off. And this is something I talk about at length in the session 2 guide. So this is something that you are more than welcome to explore in a great bit of detail. And I would very much encourage all of you to do this in your own time to make sure that you can do this. So we have this map. We can now start doing things with it. We can now start taking data off of it, and we can verify, for instance, if I turn this off, I zoom in on some of these features. Let's see how good I did when I did this a while ago. So notice that there's a bit of a shift there from here to here. So that tells us that, you know, we're not far off, right? This escarpment is pretty well matched here, but there was a shift. There's error, and we have to account for that. But it looks like it lines up pretty well with, you know, what we're interested in with GITO. So if we're happy with that, we're actually coming up pretty close to the end here. So I definitely want to do a bit more before we end for today. But hopefully you're all happy with that, and yeah, we can move on. I just have to figure out where my presentation went. Okay. We have georeferencing. Yeah, again, for reference, this is our static map. So keep that in mind. What we're going to do. So I've been saying we're going to extract data from this map. This map is useful for us because it tells us where the hazards, different modeled hazards have gone in the past, but we don't have access to the underlying spatial metadata. So we've had to georeference it. And now it's our job to essentially recreate or trace over the base map. And this goes back to a question that was asked about an hour ago. How do you actually make a shapefile? We're about to do that. We're about to make our own shapefiles to define these different hazards. So in order to create new features, this is a sort of a troubleshooting trick I mentioned last week, that when you are adding data to your QGIS, you're using the add layer option often. The other option you have is to create a layer. And when you create a layer from scratch, you're essentially creating an empty container that layers can be sort of, that features can be added to. You're essentially creating an empty file that you're going to populate with data when you use create layer. So I'm going to do this in a moment. I should note that there are definitely smarter ways to do this. You could use some more advanced image processing algorithms to extract some of these features probably. I think for the purposes of this beginner course, where it's not worth doing. I just saw a great question in the chat I'll get to in a moment. And while we're doing this, I'm going to show you this in a moment, but while you're going to go through and you're going to make a shapefile, in order to do this, you're essentially tracing, you're essentially drawing over the features on the base map that you want to extract. And the end product will be a polygon, in this case, that corresponds to, say, the area where the 10th century pyroclastic density currents went, this yellow area here. Crucially, when you do that, the amount of relative error that's introduced by you doing this is non-zero. It's relatively small, but it's affected by the scale you do the tracing at. If I were to do it at this scale, which is probably like 1 to a million or something like that, where it's very zoomed out, a misclick to the left, like if I'm trying to get the boundary here, but I misclick and I go to Mindo, then that's a pretty huge error. That could be on the order of hundreds of meters potentially. So you want to make sure you're tracing at a pretty high resolution scale. I would say probably around 1 to 100,000 for this scale map would be my rule of thumb. When I actually made the shape files that are already included with the exercise data files, I did this at 1 to 50,000. So that's something that you could do as well. So here we go. All right. There's a great question in the Q&A. Using shape versus using .shp versus .gpkg file. That's sort of a great question that I didn't want to jump into right now, but since you're asking, I might as well mention it. So you'll notice in the GIS base layers that all of the files I've made, this is the other way I've made the file, and it's not sort of a default one, is they're all given with the extension .gpkg. And when you expand this little stack here, this little, like, I don't know, sheet cake or layer cake it has the option to be expanded, you see a polygon layer below that you can then load into your QGIS. So GeoPackage, there's a lot of detail here that I could get into, but just to keep it simple, GeoPackage is just an alternative distribution, an open source distribution of vector data files that is different than Esri's proprietary shapefile format that's been standard in the geospatial industry for decades. You can still make and manipulate shapefiles in this software and import them into ARC. GeoPackages will not be easily imported into ARC because they're a different file structure. But critically, GeoPackages, they're really nice in a lot of respects for lots of different reasons. And if you just Google, what are the differences between GeoPackage and shapefile, there are lots of articles that have been written about this. There's lots of advantages to using a GeoPackage file. It's much more efficient storage. It's safer storage if you're doing remote connections. And it's just the preference I have is using GeoPackages often for my work. But for your purposes in this course, a shapefile is totally fine. The choice doesn't really matter. So when I create the features, as I'm about to do in a moment, I will create them as shapefiles, but I encourage you to experiment with GeoPackages because you add them actually in a different way, right? You don't just double click on the layer. They're essentially containers that can contain multiple different files all at once, which is really nice. And you noticed what just happened there was the first QGIS crash of the course, which is, I'm shocked it took us till session 2 to get there. So it's going to take a minute for my computer to load back up. But this is very common with all GIS softwares, the fatal crash that happens out of nowhere. Hence why you want to make sure any temporary layers are always made permanent when you think you need them. You're regularly updating your project save. You're hitting save project a lot. All that needs to be happening pretty regularly. I have lost days worth of work before on GIS from a fatal crash like that. And in this case, I did not, because all this is backed up so much. Ben, I'm not sure about autosave. If that's an option, actually, I would love to know if that's an option. Because I don't do that. But the thing is, if you turn on autosave, that would work for the project file, but that wouldn't work for the layers. When you're manipulating individual layers, you have to manually specify when you're exporting them, making them permanent, or in a moment you'll see making changes to the layers. Okay, so we are running right to the end. So I'm just going to do this very quickly, and this is where we'll pick up next time. So if I load back in this map here, I want to extract the extent of some of these secondary lahars. For instance, this one that's going into Quito. So to do that, I'm going to go to Layer, Create Layer, and like I said, I'm going to do a shapefile layer. You get a lot of options when you do this, and I'm going to save this in, again, my live demo, and I'm going to do VMSG sec lahars. See the name of the layer. Keep encoding the same as always, and then these are going to be polygons, right? They have closed geometries. They're not individual points. They're not just dimensionless lines. They have area. And we're actually really interested in that area. Want to make sure we have this right projection system. And then we have an option to add a field. I am going to add a field, and I'll explain why later, called area. Oh, no. Okay, yeah, sorry, I thought it crashed again. I was going to be very upset. Yeah, area meters squared. We'll do decimal number, and we'll add this to field list. I'll explain this more at a later date. But when you create a new layer, you can actually start from the beginning. You can add fields that you can populate later with real data. That's something nice to know. So I hit OK. I'll add this to overview. There we go. And now it says that there's something here, but there's nothing displaying on the map. And that's because we haven't actually created anything yet. So to do that, you're going to have a layer selected, a vector layer specifically, and you're going to click this pencil icon. This is the editing toolbar, one of the most commonly used toolbars you're going to access in QGIS. You toggle that on, and a lot of different options become available as soon as you do that. The one we care about for polygons is this add polygon feature, which is this green blob with a yellow dot. If I click that and I zoom in to, I'm at 1 to 30,000 right now, which is pretty high resolution. What I'm basically going to do is left click until I can trace around the extent of this whole polygon. So you see, I mean, this was actually a lot of my undergraduate research, was extracting data from geological maps. It had to be georeferenced, and then I had to pull out the relevant polygon features. So I have done this for you. Never fear that those layers already exist. You do not have to do this yourself necessarily, though I do encourage you to give it a whirl. I'm being quite imprecise right now just to show it live, but I get to the end, I right click, and then I get an option to save. I will say, this is ID1. This is our first lahar that we've traced. And ta-da, I've created my first shapefile layer. Crucially, you have to save these edits. You've edited this. You can delete points too by doing this. If I hit save layer edits, and then I click off this, it's permanently saved in the location that I loaded it in my hard drive. Sorry, I didn't mean to load the properties there. So what you'll have to do, or what you can do if you so choose, is to go through and click through and do that all yourself. Thankfully, I've already done that for you. I have to remember where I put it. I believe it's under hazards. and it's under, we'll load, yeah. So it's under hazards, and it's called lahars.shape. So I turn this off. Here's what we've done today. We've imported data, we've reprojected it, we've georeferenced a map, and then we've extracted all this information. So that gets us to the end of our day today. I don't want to go over because I know other people have things to do. I want to thank you all for sticking with me in the official time. And I'm happy to stick around for a few minutes to answer any further questions. For next week, we're going to be hopping in session 3. We're going to pick up where we left off here and try to finish off this exercise. There's not that many more steps to go. And then we will jump into intermediate GIS. And that is going to be a lot less you doing work and a lot more watching me and trying to understand some of the analyses I'm doing and why I'm doing them. So there'll be opportunities to be interactive, but you won't have to do as much. It'll be a lot more observational. So yeah, I want to thank you for your attention.
Amazing. Thank you so much, Nick. So I guess maybe I can ask you some questions whilst we kind of people maybe trickle out.
Sounds great.
Somebody asked a while ago, is there a standard method for determining what to use for the target EPSG, depending on the data type?
That's a good question. Target EPSG depending on data type. Not that I know of. That's what I'm going to have to say for that one. And it's also, and part of that is because I haven't had to work with aerial imagery that much. I'm not that familiar with that data type. That's something I'd be happy to look into, but I think that's where one of the boundaries of my knowledge. I mean, just in general, for every different problem, you're going to need probably a different projection system. You don't need to have the same projection system even necessarily within the same starting point for a project. You can, down the road as your analysis progresses, you can reproject those layers later and make sure they line up at the end. I think that would be the goal. But if you had two different data sets that you need to kind of combine downstream, I mean, it should be okay if they have two different projection systems, as long as you're consistent and you make sure that you can marry them up at some point. That would be the best answer I could offer. It's a bit muddled, but hopefully that helps.
I guess we'll take the quicker one first. The draw polygon icon, can you just show us where that is again, please?
Yes. So if I select my VMSG secondary lahars layer here, I click edit, and then it's this green icon. It should be 2 over from the pencil. It's a green blob with a yellow circle. Hopefully, I'm kind of wiggling my cursor a lot. Hopefully it's showing up on your screen. And yeah, when you click that, your cursor becomes a little target reticle.
And then maybe we'll stick with the polygons a second. Sorry, Elliot. Is it better to handle polygons in QGIS or in a graphic software and then georeference them?
It depends on the problem. Honestly, I would say it's a matter of personal preference to some degree. You could obviously get really high resolution traces in an image processing software. But if you do that, then you have to georeference vector layers that, I mean, potentially are stacked in raster bands, but you're going to have to figure out a way to actually then georeference those traced over features. To me, that does sound just as challenging as doing it in QGIS, where obviously the graphic design tools aren't as good, but you have verifiable other data layers you can compare and verify that you're selecting the right part. So my answer would be try what you're comfortable with, but also keep in mind that even though you're tracing it in Illustrator or Inkscape or whatever, or a fancier software I don't know about because I'm not a graphic design person, there are still errors you're introducing as a user by extrapolating that, and you have to account for those. Like I said last week, you have to keep a log of all the different errors you've introduced to make sure that you propagate the uncertainty properly.
How do you finish drawing the polygon once you've once you've started and you've drawn it, how do you finish
Yep.
it and save it?
Thanks, Claire. When you click around, you're happy you're done. Here, I'll just highlight this. I will turn this on. Just drawing this here. I'm happy I'm at the end here. I right click. And when I do this addresses another question I just saw come up. Does every polygon get its own name? Absolutely can. So when I right click, this is me committing my edits, creating my new feature that I'm going to add to this polygon collection of polygons. Sorry, the shapefile collection of polygons. And the two things I'm allowed to populate are ID, which is a number I can assign. This is the default attribute that every shapefile gets. I could also, if I knew in advance, I could say what the area in meter squares are. This is a field I added. But to Tara's question, I could have added a field called name and said that this is the, I don't know, the Quito Lahar versus, you know, I don't know, some other locations Lahar. So when you right click, you get the option to populate with that kind of metadata.
And then can you see each of the polygons that you've traced within the layer after you've named them?
Yes. So this is my original layer here. If I right click on it, I go to properties, and this is something I'll talk more about in the coming sessions. And I go down to, oh, sorry. Go to open attribute table. That's what I need. Notice that, again, I'm going to use the identify tool, which I used during the break. Each of these is their own discrete feature. And if you notice on the right here, this ID value is changing as I click. This is letting me know that there are 13 individual Lahar polygons within this shapefile. And as I click, I'm sort of cycling through, going to different ones. There are all sorts of different sizes and shapes in different areas, but they're all in the same shapefile. And the only thing that lets me know what they are in this case is a pretty poor documentation on my part, just sort of a numbering scheme. I could have added names. I could have added a lot more metadata. But yeah, you can see those show up through the attribute table.
So then if you wanted to export or extract some information about each of these polygons, say the area, the length, is that something we'll cover in the future, or is that something that
we're doing it next week? Yes,
okay,
Tara,
great.
you've anticipated. Yeah, Tara, you've anticipated it correctly. If you even read the session 2 guide, you'll see how we're going to do that. But yes, we're going to do that.
In that case, we'll circle back to Elliot's question. Since the original map was from ARC, would linear transformation in the georeferencing options be a good choice here?
Yeah, I mean, it's a good question. I mean, as with all of this, like projection system, like the method that you use, there are, you know, to extract these vector shape files, every step you do in GIS, there are probably 4 or 5 different paths you could take to get to the same place. So a lot of this is going to be what works for you in a lot of respects. And in this case, your suggestion that we use the linear system, I mean, that very well could work. I haven't actually tested to see how well it compares. Probably be a good test to do if I was, you know, doing this as a research project or trying to write a paper on this. But critically, as long as you declare it, it should be fine, right? Like as long as you say, I did use the linear georeferencing system so people understand what you did, it'll be a fine choice. The reason why I wouldn't say linear would automatically be better is because we have an image, a JPEG file of a particular resolution. It's so many pixels by so many pixels. That resolution has no bearing to the actual physical scale of the area. So when we actually add these points, even though we know that this map existed as geospatial data at one point, now it is not geospatial data. It is just pixels with colors that don't correspond to any real geospatially relevant values. And we can't assume that the scale of that image scales with the topography the same way we're looking at it. So you can't just assume that a linear transformation works automatically better. And this is particularly the case where you're working in bigger areas. Like when I work for the whole of India, that's a huge part of the Earth. And when you've projected that in 2D coordinates, there's a lot of curvature. And the thin plate spline algorithm and polynomial algorithms do a good job accounting for sort of curve, at least in my experience, seem to account for curving very well in the distortion. the linear may not do as good a job. So if you're working in a really small area, linear might work well. And it may end up turning out linear does work well for this area. But starting out, I don't think it would be appropriate to assume it works better necessarily. That's my best. That's a really good question though, because that's an assumption I'm making. The point being with all of these questions though you all asked is that there are multiple ways to get to the same destination. As long as you're documenting the choices you made and the uncertainties that introduce, and you think critically about why you've done it that way, you can back it out and you can defend your sort of way of approaching this. Some of the ways I approach these problems are just ways that I've taught myself to deal with GIS. So you will come up with your own solutions as well. You can't learn all of this from a book because a lot of it's kind of like learning how to be handy around the house. You kind of just have to learn a method that works for you and tools that work for you. And everyone's going to do it slightly different. So when you try to help your parents build cabinets, they'll be mad that you're not doing it the way they want it to happen. But all of that to say that any of your methods are valid. Mine are just sort of guidelines to help guide you as beginners. So don't be too stressed if you try something different and it looks different.
Okay, amazing. I think we made it to the end of the questions.
Cool.
So
I'm going to stop sharing now.
If anybody has any additional questions, feel free to drop them on Discord in the week and we'll try our best to get back to you. But otherwise, thank you very much for joining us. Thanks, Nick, for such an awesome session. And we'll see you next week, same time, Wednesday. We'll send out an email tomorrow with the recording in case you want to review anything or watch again what Nick was doing. But otherwise, we'll see you next week.
Thank you, everyone.
Thank you, everyone.
Should we stop the recording?
Yes, I'm just working on it.
Oh, okay, yeah.